Are you taking calculus for the first time? Well, this is a series to get you well prepared for your calculus class by reviewing some of the essential skills that you need mastered to do well in calculus. Here we're starting with the concept of rates of change. So rate of change is a very important concept in calculus. It is when we have something that changes with respect to something else. So a good example to understand rate of change would be like speed or velocity, where you have a change in distance or position with respect to time. That is like miles per hour would be a change in miles with respect to hours. So if you had, say, a car traveling along a straight road. So let's suppose that you travel for 50 miles over 1 hour period. Do you know what your average rate of change would be? So if you said 50 miles per hour, that would be correct. Let's just look at a graph of what this might look like. Let's say this is your distance versus your time. And this distance, let's say, is in miles, and the time is in hours. Let's say you have a graph like this. So let's say that this is at 1 hour here, and let's say this is 50 miles here. So if we think of this as slope, if you remember about slope from when you took algebra, slope would be the same as, remember, rise over run, or it would also be the same as the change in y over the change in x, y2 minus y1 over x2 minus x1. Now in this case our y2 and y1 really be distances, and our x2 and x1 would be times. It's going to be the change in your distance over the change in time, or your change in your position over change in time, technically. So here we would have a change of 50 miles over the change of 1 hour, and that would get us 50 miles per hour. Now this would be our average rate of change. So this will actually be the average velocity for this car traveling that 50 miles over that one period of time. So let's look at what this means graphically now as well. So this slope that we just did, 50 miles over 1 hour, we were looking at the slope actually from the origin to this point here. And we're starting at a position of 0 and a time of 0, or this point right here would be 0, 0. And then this point right here, we're going to have the time of 1 and the distance or position of 50 miles. So 1 hour, 50 miles are where our x coordinates or t coordinates are, would be the 1, and our y coordinates or the miles or the distance coordinates is going to be 50. So again, if we think of this as rise over run, we can think of this is the rise, and over here this would be the, so yeah, the run of 1 and the rise of 50. Or you have y2 minus y1 over x2 minus x1 would be 50 minus 0 all over 1 minus 0. That's your 50 over 1, or 50 miles per hour. Again, this would be the average velocity. So this line right here is what we call a secant line. So this average rate of change would also be the same as the slope of this secant line. So a secant line would be a line that goes through 2 points on a particular curve. So this black curve would actually be our function, which would be our position versus time graph. And this would be our function, say, we could call it, say, y equals, say, d of t, where we would have your, again, your independent variable being t, your dependent variable being the d, or you think of that as y. But this would be your graph I mean, this would be the slope of a secant line. So again, this is your average rate of change, but you're not actually traveling 50 miles per hour through that whole trip. Based on this graph that we drew, it's not a constant speed or constant velocity the whole time. What's happening here is at any particular point in time, you're actually going different speeds. And this is just the average rate of change over a specific interval of time, which in this case was 1 hour. So what we could do is look at what we call an instantaneous rate of change. And if we wanted to say, let's say we wanted to find out how fast we were going right at this particular point, what we could do is look at the slope of the curve right at that point, or this would actually be what we call a tangent line to a curve. A tangent line would be a line that intersects a graph in one point, and at that one point it's going the same direction, or it has the same slope as the curve at that point. And it would be like if you're driving along in the car, at this particular point, your speedometer itself would not be showing 50 miles per hour. It would be showing whatever the slope of this curve is. So the average velocity was the slope of the secant line. An instantaneous rate of change, or the speed or velocity that is right at this point, would be the slope of that tangent line. So we could say the instantaneous rate of change, that would be equal to the slope of the tangent line. Also, one way to think about a tangent line is, suppose, say another scenario here, suppose we have some graph, and suppose this is like a road that you're traveling along, and you just happen to say, along this road, all of a sudden you decide to go straight, or you go off on a tangent instead of following the road. Maybe there's a road that goes off straight from this road. So this tangent line, again, would be in the same direction as the curve is sloping right at that point. So that's the idea of a tangent line, or the slope of a tangent line. It's going the same direction or same slope as the curve at that point. So if we can find the slope of this line, that will also give us the instantaneous rate of change, or in this case, our instantaneous velocity right at this point. Maybe this is like, what does that look like? A little bit less than half an hour into the trip. Let's say this is like 25 minutes into the trip or something. We can find exactly how fast the car was traveling. Now, you could also compare this slope. Of course, this gets into the next video that we're going to talk about in terms of what slopes look like. But just as a little precursor of that, we have this slope is steeper than the average rate of change slope. So the car is actually going faster along here. We could talk about that more in the next video. But the key thing, again, for the slope of the tangent line, that's going to be the instantaneous rate of change. That's like looking down at the speedometer. The average rate of change would be your average velocity over that whole trip. Now, in terms of calculus, this is then related to something called the derivative. The derivative is going to be the same as the slope of the tangent line, as well as the instantaneous rate of change. So the derivative at this point is going to be, again, the instantaneous rate of change and the slope of the tangent line. This will be the same as the derivative at that point. So that's a little glimpse into the calculus of this. Stay tuned for another video. We'll talk about slopes on graphs and different types of slopes. So if this helps, give me a like and subscribe.